which just means it's going to be on half the time and off half the time. So my interval I want to be the same. Okay, I have to figure out how to turn on interval, mode single, mode repeat. Okay, so I'm 0.1 and 0.1. So now it's just going to flash on and off. And that's ready mode, standby mode. So now it should fire. Now lasers can make light that's too bright for our eyes, like welding. So we're going to want to not be staring at this while we fire. I'm also going to turn off the slit lamp. So this is really eyeglasses. Yeah, so these guys, yeah, we can put a bunch. Yeah.
So we can use that on just the
Everything you can reach. You
on the mirror?
Yeah.
Okay.
So this, see how that mirror is just also weird looking? It's kind of gold.
Yeah.
So it's a higher power mirror. It's a first surface mirror, so the surface that you see is the shiny surface. Your bathroom mirror, if you touch it, you'll see that you're not touching the shiny surface. Yeah. But with lasers, you get the first surface shiny. We're on there. We'll plug this into my computer. And then we're off, which means the interval is 0.0. In this mode, remember we had to set this to R for repeat. So it goes, I don't know what that is.
That's pulsing.
Yeah, but so is repeat. Oh, this is, I think micro, this could be micro pulsing. Did they have that then? Because look at the pulse changed when I did that. So there's continuous wave. So then we just fire and it just, as long as we're holding down the foot switch, it's firing. And then single shot, we can't turn on the interval in single shot. But if we go to repeat mode here, then we can do 0.1 and 0.1. So 50% duty cycle. Okay, Elijah, would you push that foot switch?
Is this something we're going to have to do when we get there?
No. Voltages for the YAG flash lamp to fire at. So we can go into YAG mode, and so we've selected YAG, and then we can confirm that that's what we want. And now we're in YAG mode, and it's in standby. That's good. We're going to push and hold the standby button. Push and hold, and it'll drop us into a menu called operator menu. This is where you adjust things like the display contrast and the volume of the beep. And if you had a foot switch, you could select that. Now we're going to do the same thing again. We're going to push and hold this for 5 seconds. That's going to put us into service menu. Service menu is kind of behind the scenes. It's broken into 2 different display windows here. This first one will scroll up and down with several different options, and then we can hop down to this lower section, and this also gives us different options, and I'll just briefly describe it. I don't think you'll need this, but if you have to do any troubleshooting over the phone, this would be actually helpful for you to have. Okay, so right here we're in YAG mode. Now we can change whatever the highlighted is by using the energy dial. That's this lower of the 2 knobs. So we're in YAG now. If we switch this, now we're in SLT. Back to YAG, SLT, okay? Now let's go down 1, that's in standby. We can change from standby to ready with a click of the knob. We're getting this icon because it has a tall illumination tower and it's blocking the YAG beams.
Right.
We're going to need to move this off to the side a little bit and try that again. Now we're in ready in YAG mode. Next up, I'm going to come over to this top right number. That is the energy display. So we've asked the laser to fire at 0.3 millijoule. The lower number is what the laser actually test fired at.
How do you know? How do we know that? I mean, it measured itself.
So when we turned it on, now I'm going to show you when we dial in 1 millijoule, it's going to take 3 test shots, and each of those test shots will display the energy of that particular test shot.
So you can
right here.
self-test this thing.
Well, but how do we know that 0.3 is actually 0.3?
Yeah.
It's with this. So we're going to calibrate it, and then yes, we know. So we'll go up to 1, and we're going to see. So right there, it went 1.2, 1.0, and then 0.9, I think. So that's great. If we saw that all 3 of those test shots were too high or too low, I'd want to make an adjustment. And these, if you're getting an error code, you can see kind of behind the scenes what the laser is seeing and this will allow you to really kind of get under the hood. Now back to the thing that we'll want to do.
So wait, so you've got it at 1 and it tested at 0.95. That's close enough?
Oh yeah,
Okay.
it's very good.
Well, yeah,
So
that's
yeah, with pulse lasers, each pulse is a guess. And so the laser is going to set itself up to get as close as it thinks it can, and it can make adjustments as you go. Okay, we're going to go back up to the top. This is DAM, stands for diode aiming module. That's your aiming beam.
Where does it say DAM? Oh, DAM cal.
Yep. So then energy curve is not used. Energy monitor is what I'll be using with my meter. You won't use that. Voltage window. We will come back to this, and all we're going to do is enter it, and then it's automatic from there, and you walk away and come back in 20 minutes. It'll be done. But I'm going to continue the tour to serial number. So this is where your version of software is set. Now, this particular hardware set, while we still make the Tango, this is a version 2 Tango, and we've moved on from that. So these software numbers are probably never going to be updated. We call this 1112, and this is probably what it'll be for all time, because it's a discontinued laser and it works well. Pulse totals is just that. So this doesn't actually mean that the laser fired 43,000 shots. It just means that that's where the pulse counter is. So we can go in, I can look at service documentation, and we'll see what it's actually been historically. Okay, I forgot to say, okay, so to get out of it, you just push and release. And then we get
Push
this one. So if we're in pulse totals and we want to get out, we can just push and release the round button. Okay, back up here, pulse totals, and then we have view constants. So these are like internal numbers that the laser has stored in its memory in order to operate. So most of these are not, it's not things that you'd have, but I might have you say, oh, can you get me the single pulse voltage? That's SP voltage. That's the 517 volts is what this laser uses to fire and to get one pulse. It uses 597 to get 2, and it uses 653 to get 3 pulses.
Wow.
Okay, and yeah, these things are probably not going to be helpful, so we'll go back out, and then we'll go up to voltage window, and all we have to do is hit the enter button, which is the one with the circle above it. Now what this test does is it starts the laser power supply at 350 volts. It takes a shot and it sees, did I get a pulse from that? And the answer will be no, and you'll see that right here. It's getting 0.0.
Is that good?
That's what it should do. So it's firing at too low of a voltage to get a pulse, and it's going to continue to ramp up. Now we're at 356, and it'll keep going until it sees, oh, I get one pulse at 470 volts. So that's the beginning of the window. And then it continues up and up and up, and then it starts to get 2 pulses. And it says, okay, so from 490 to 525, I got 1 pulse. So I'm going to set the voltage about in the middle, a little bit high of middle. That's my single pulse voltage. So it's least likely to underpulse, least likely to overpulse.
So this is also a self-test that's going on in the laser.
Yep. And this really doesn't rely on the calibration of the laser. This is finding the optimum voltage for the flash lamp to fire. So if you wanted to run this every year, that'd be a good idea.
Okay.
Yep.
And the SLT part of it,
it's all the same.
Okay. You don't have to do anything differently for that.
No. So I'm going to turn it off now, and because we don't need to run that right now unless we see underpulsing. Well, it might be good to run it, but I don't need to have everybody waiting while I do that.
Okay.
Or Ethan, why don't you put that on the pad so that we can be ready to pack it up. So don't connect the wires. We first route the wires. So that's going to look like this. We go back under here, tuck them in, loosen this up, and we go to all the way to an extreme. We're hitting the screw here. We're not hitting the screw here. Okay. Now they're hitting both sides at the same time. Now that wire is heading towards the doctor. Then on the left side, it's all tucked in under there. At this point, if we're setting it up, we can then connect the wires because the cable is routed properly. Now it can be connected. If you connect them first, then you're fighting those cables, and you can have a lot more cable noise and drag as you move this around. Right now, it's just
How heavy is this thing?
beautiful.
Where's the best place to grab it?